Hello, this is Mr. Froelich. I'm hoping that by now you have watched the other screencasts for this week and you have completed the atmosphere layers worksheet. This screencast is designed to just highlight a few of the basic things that I want to make sure you have in your brain for this topic. I am not going to go through the basic information for each layer. I'm hoping that you did that already. What I am going to highlight is the structure and behavior of each layer that you maybe had already written down on your sheet, but this is something that I really wanted to make sure that you had. So what I'm showing you is a basic representation of the layers of Earth's atmosphere. Now you'll notice not every layer that I asked you to research from that website is on this diagram, and partially because after you get up into the thermosphere, you're basically in space. Yeah, there's gas there. Yeah, it does things, but climate-wise or sort of like conditions-wise, you're basically in space. So each of these layers here, the troposphere, stratosphere, mesosphere, and thermosphere, are all broken up by what we're calling the tropopause, which is the top of the troposphere, the stratopause, which is the top of the stratosphere, the mesopause, which is the top of the mesosphere, and so on and so forth. So each of these layers is broken up not by the gases that make them up. The air that makes them up, for the most part, is essentially the same. It's going to be almost the same breakdown of gases, the 78% nitrogen, 21% oxygen, so on and so forth. The things that makes these layers different is the way that temperature will be fluctuating all the way throughout these layers. So what I've done is I've highlighted the air temperature pattern line, which is in purple, and you don't have to necessarily pay attention to the numbers. Yeah, it gets really cold as you go up, but what I want you to pay attention to is the trend and the spot where the trend changes. So if you're looking at this, you'll notice that in the troposphere, as you go up in altitude or height above ground, temperature goes down. And then you reach the tropopause, and all of a sudden that pattern changes and it starts to get warmer as you go up. That's right. This is sort of a fact that many students find very surprising, that in some layers of the atmosphere, it gets warmer as you go up, which is the opposite of what we would expect. So in the stratosphere, that temperature increases until, guess what? Oh, you reach the stratopause. The stratopause is the location where we now are in the mesosphere, the next layer up, and again, the temperature profile changes. So what you'll notice is that every single one of these changes of the layer, that's also the spot where the trend of the temperature changes. Okay? Now the other thing that I'm going to show you is the trend for the air pressure. Now this one in green is not very surprising. Basically this says that the farther you go up, this green line, the farther you go up above ground, the lower the air pressure is, and it drops off very quickly. So at the ground, we have what we're saying is 1,000 millibars, which is exactly 1 atmosphere, or 1 ATM. Don't forget. What that means is as I go up, the pressure drastically drops very quickly, to a point where you would need to have a suit or a cabin or something enclosed around you like an airplane to keep you alive. Now the last thing that I'm going to highlight on this particular screencast are some of the basic objects or things that you will see at each layer, just to kind of give you some perspective. So one of the things that was discussed in the worksheet website was that all of the clouds and weather will be in the troposphere. One thing it maybe didn't highlight that we would normally highlight in class is that airplanes tend to fly right at the tropopause, and there's a reason for that. The stratosphere is a very stable layer, and if you are trying to fly an airplane, generally speaking, pilots will purposely fly in the more stable air to reduce turbulence. Mount Everest is almost to the top of the tropopause or the troposphere, which kind of puts things in perspective. The atmosphere layers are relatively thin. For example, the troposphere stops at about 10 or 11 kilometers above the ground. 10 or 11 kilometers is not that much distance. That's less distance from St. Cloud to Clearwater. Okay, so if you take that distance and you move straight up, that's how, we'll say, thick that layer of the atmosphere is. As you travel into the stratosphere, you will have weather balloons that go into this part. Now, after you get through the tropopause, weather stops basically. So most of the job of weather balloon when they reach this height is done. If you continue to travel to the mesosphere, this is where you will see meteors burning and other shooting stars, because finally the gases in our atmosphere in the mesosphere are thick enough to start burning them up with friction. Now, in reality, it's still very, very thin up there. You would not be able to survive or breathe if you were to go to the mesosphere. And then lastly, space shuttles that orbit the planet are in the thermosphere. That's right. What we would normally sort of consider as space is technically still in our atmosphere. There are some scientists who have struggled to put an actual boundary of where our atmosphere ends and where space begins. In reality, our atmosphere sort of just fades off into space, and there's really no definite line. This will conclude this section of the screencast. If you have questions, feel free to message me in Schoology or to log in to the Google Meet time, and I will be there to answer any questions that you have. Thank you, and have a good day.